Uh, we are honored to have Dr. Bunil Kumar sir. Welcome you sir in second day of AICTE Training and Learning ATAL Academy, a sponsored 5 days faculty development program on robotics. Sir is currently working in the Department of Computer Science and Engineering at NIT Meghalaya. He has completed PhD from NIT Rourkela on robotics vision. He has more than 12 years of teaching experience. He has more than 4 years of research experience as a JRF and SRF at NIT Rourkela. He has published number of research papers in reputed journals and presented his papers in many international conferences in India as well as in foreign countries. He is doing research in the field of robotics, image processing, biomedical image analysis, and cybersecurity. I invite you, sir, to deliver the session on vision-guided robotics assembly application. Thank you, sir, for joining the session.
Thank you for inviting me. Let me share my presentation.
Yes, sir, it is visible.
Okay.
Now you can start.
Okay, thank you. Let me inform some information before starting the talk or going into the depth of robotics vision. I hope all of you are aware of some of the components in a robotic system. Today I'll be discussing about vision guided robotics, in which I'll be talking about robotic assembly system along with some recent development we did in the laboratories at NIT Meghalaya also. Let me, is my screen visible in full mode?
Yes, sir, it is visible. Vision guided robotic system. It is visible, sir.
Okay. Let me make it full screen. Yeah, I hope the participants who are there in this discussion, they are aware of the sensory components available in a vision system, in a robotic system. So I'll be talking about the basics of basic applications of vision guided robotics and the development, how we can choose the different components which are required for developing a vision guided system. So coming to a robot intelligence system, all of you know the definition, right? No need to talk more about this. But in general, it is a programmable, multifunctional manipulator designed to move certain materials, parts, tools, or specific devices through different programming modes, right? So robot is a device through which you can give certain program, and based on that it can act. So you give certain input in terms of data, whatever you have, and you can expect certain actions from the robot. Then the cognitive robot, whenever it comes, it is a basically intelligent robot which behaves intelligently as a human being. Where there are a lot of complicated scenarios. If you talk about this a specific example, the robot is holding a ball. Now you see, in a normal sense, you can understand, if I hold a bottle, how much force I need to apply. If it is a glass made up of the material is glass, then how much force I should apply so that I can handle it properly. Then next come into effect that suppose I have a pen, right? So how do I hold the pen? In which way I'll hold this way, or I should hold this way, or I should hold this way. So in which way or in which position I should hold so that I can have a stable grasping, right, by my fingers. So intelligent robot is talking about it should behave like a human being. So like a human being, we understand it is a object which is made up of plastic. So I can apply certain force to hold it properly. But if it is a glass, the same force I cannot apply to other material, the object which is made up of glass material. So depending on the material, the force we are applying should be changing. So the intelligent robot should behave in that way. It should understand the material, it should detect the material, it should find out the position, where should I grasp. Along with that, it should understand overall scenario of the shape, size of the object it is going to hold. So this ball is a circular object, right? And it is made up of plastic. So the robot has to put the fingers in such a manner it cannot go out. So that is all about the cognitive robot, or you can say intelligent robot. Then coming to what are the different elements, basic elements which are required to be in the robot so that it can intelligently behave. There are effectors, there are sensors, there are different architectural models, there are different integration of different inputs, and applying certain emotions, right? So if you look at this diagram, there are a lot of sensors are available in the framework of the robot. Here it is visible as a vision sensor. There will be force or torque sensor. There will be ultrasonic sensor. So there are a lot of sensors we can go on applying. So I have in my presentation, in my discussion, I have different varieties of sensor and which sensor is required for which particular task. Next, coming to the particular part, the effectors we have. Effectors basically, or we can say the actuators, it's a kind of sensor which perceive certain information and give information to the robot so that robot can perform some certain task. So there will be a degree of freedom in a robot, right? That means all of you know, all we are not Baba Ramdev, so that we cannot put our hand in different position, right? So we have certain reach, we have certain limitations. I cannot reach beyond my limitation. So degree of freedom is in the specific environment, is the specific workspace where the robot can do the task effectively. Then locomotion, either you can go for, you can think of the scenario where it is a static scenario or it is a dynamic scenario. Then manipulations, we can go for rotary, or we can go for prismatic motion, we can go for end effectors. See, this is the one of the sensor integration we did at NIT Meghalaya, where we have taken care of 5 varieties of sensors: force sensing, tactile sensing, sonar, visual, and proprioceptive sensing sensors we use. Now coming to why these sensors are required. Because I hope in the discuss as the computer science is organizing this particular FDP, in this what is the role of the computer science student here? What is the role of the computer science researcher here? Because the sensors, they provide the data. So now the data analytics comes into effect. So how do you analyze the data? How do you know how much force is required? How do you know what is the distance of the object from the robot end effector? So that measurement also need to be calculated properly. So that is all about, we are analyzing the data and we are getting the proper output so that we can feed this information to the robot, and robot can behave intelligently. Now see, there are varieties of sensors which are used in different applications in medical domain, in proximal domain, in distal domain. So robotic sensing is categorized as basically external sensors, because robot is a device. We are adding a lot of sensors to it. Though it has some internal sensors, but internal sensors is not always making the robot intelligent. Just like if there is a joint, right, how much angle it can only bend. The sensor is there, it can give an indication that up to 30 degree angle it can bend only. Or if it is elongating in a particular direction, so how much it can. So that also the sensor gives the information to the robot controller, so that the robot can understand, I can only reach up to this, or I can only bend up to this. So coming to in different various different applications, there are different sensors used. Vision sensors in the industrial applications, vision sensors basically 24% are used, and proximity sensors 3%, infrared, touch, optical, force sensor. So there are different varieties of sensors used in different industrial applications. So this diagram is not like I am giving you in a fixed manner. This based on the research and study, we found out that these are the sensors which are used in different industrial applications, and what is the percentage of their use. Coming to the architectural development, or you can say the control system development, robot control refers to the way in which it is sensing and performing certain action based on the sensing data. That may be different because all of you know, when in your childhood age, whenever you don't know how to put your lace or how to put your tie, your parents are teaching you. So what you are doing there? What is the scenario there? You are just either you are getting the information visually, and you are collecting, you are processing, and you are feeding it into your mind to learn or to perform at your own. So there is a feedback control system every time the robot is always dependent on. So there are different control approaches. Reactive control, where it is not going to think anything. You give certain data, it will perform. Behavioral based control, it has to think the way you act. That means your parents are doing, at the same time you are learning and doing it. That's a behavioral based control. Deliberative control, it is a very, that means at the current stage you learn, you think, you store your particular learning informations, and later you act on that. Later you perform on that particular task. Then there is a hybrid control, where all these three other kind of controls are performed in parallel in nature, right? You can think, you can act independently. So behavior-based architecture, we all of you know, we have the sensors which is sensing, which is acquiring the data. The actuators, it is going to perform certain thing. In between them, there are a lot of things, a lot of tasks are involved. Reasons about behavior of the objects. You need to identify the objects. You need to build the maps in which the robot has to perform, in which path the robot has to follow. If it is a mobile robot, the path is an important concept, important parameter, which you need to construct, which you need to develop. Similarly, if it is in an industrial robot, also the path is also important, because you might have seen in different industrial applications, there are multiple robots, multiple equipments are available. So the robot hand cannot move here and there. It has a specific path. It has a predefined path through which it will move and take the object, right, and keep somewhere else. So that you need to build the map to perform a specific task. Then avoid the objects. That we say obstacle avoidance, right? In between there will be a lot of other equipments, other objects will be available. So it has to avoid the obstacles which are coming into the path. If it is a static position, if it is a static environment, then everything is known a priori. But if it is a dynamic environment, you don't know where the object is, where the obstacles are present, or when the obstacle will come or not. So you think of the hybrid control is coming into effect whenever that is the dynamic scenario, dynamic situation. Suppose the robot grip hand is moving, suddenly another object comes in front. So in that case, what will happen? The robot has to sense and immediately has to take the direction, change the direction, right? So it has to intelligently act in this way. That means immediately it has to process the information it is receiving and perform the task accordingly. So there are a lot of applications with respect to the robotic development. So in industrial automation, because in my talk I'll be talking about the industrial automation. So industrial automations, we have part assembly system. There will be, suppose previously we understand, or nowadays people are aware of, whenever they are purchasing a computer system, they are assembling, right? So what does it mean exactly? Different product or different components they are putting together and making the system, right, functional. So similarly, whenever we are taking a product, we are purchasing a product. In that case, at the industry level, if you think the product is not directly produced by the industry, it is going through a lot of phases. Separately, suppose say in the mobile phones, right? In the mobile phones, all these mobile phones contains a lot of components. So all the components are present in different bins. So the robot is there to pick and place it in proper place, right? So you think of how minutely the robot is going to do. So industrial automation is a scenario of that. I'll talk about what are the necessary knowledge we require to do such kind of robotic framework, right, in our laboratories. Services of the disabled. That means we can also provide full chair, robotic full chair that we have developed in our laboratory for a PhD student. So that we did robotic full chair. We have developed a prototype model, right? So that prototype model is going to sense the obstacle and is going to deviate from the path where it is supposed to move, right? So intelligently it is behaving. So that is for disabled persons. There will be a lot of applications for disabled persons you can develop. In planetary exploration, in space applications, there are a lot of tasks. I'm not going to talk about this particular in details. There will be mining, site clearing. There will be medical industry, whether it's robotic surgery, all of you know, heard of. There will be hazardous environment. Currently in DRDO, there is the nuclear sites, right? Because the chemicals are very reactive in the reactors, right? So surrounding to the reactors, to clean the environment of the reactor, now if you put the human beings into the work, it is going to harm the human beings. So what they did, they apply the robots, they develop the robots to clean the surrounding environment of the reactors because of the hazardous environment. Similarly, many applications are there. Now coming to industrial automation, there will be assembly operations. All of you look at this is a car assembling operations is going on. there is a packaging industry where you need to package, just like if you are aware of the thumbs up, Coca-Cola, Pepsi, right, bottles. So how they are packing. So that packaging industry is also talking about industrial automation. Pick and place kind of activities. There will be small scale assembly operations. So where chip can be developed, right? So there will be production sales where the robots is also taking major role. Now, sorry, yeah. So what sort of intelligence to be incorporated to identify this kind of industrial automation? So these are the varieties of knowledge required. We need to detect the part. We need to detect the part properties, shape, and the grasping point. As I told, the pen is there. You see how I am grasping the pen through my fingers, 2 fingers. So can I put here? Is it a stable grasping? No. If I put here my fingers, it is a stable, I can say it is a stable grasping. Stable means there is no chance of damage to the object or no chance of any disorderness in grasping the particular object. So grasping point should be calculated properly. Then position estimation. Suppose my robot hand is here and there is the workspace and there is an object on the workspace. So I need to understand, the robot need to understand where is the object present at the current moment. So position has to be estimated, right? If it is a dynamic environment, like a conveyor belt is there and the objects are moving, in that case, we have to estimate the object position in a dynamic scenario. So accordingly, the robot has to perform. Similarly, the surface of the part, particular object, and the different environmental structure. See, there are different assembly operations available. If it is a only we need to talk about to measure the presence of the object, or if there are electromagnetic object, what kind of sensors we use. If there are optical object or object of considering different optical objects. So there are different parameters or task parameters we need to calculate for different varieties of sensors we are using. Part detection, to detect whether it is present or not. Suppose there is a conveyor belt and the part is already present in the particular conveyor belt or not. How to know? We need to apply certain sensors so that sensor can detect whether the part has already arrived or not in the conveyor belt. So we need to calculate the range or distance. We need to calculate the textures. We need to calculate the softness or hardness of the object material. We need to find out the shape and size. We need to find out the roughness, magnetic properties of the object, in metallic properties or non-metallic in nature. We need to calculate the weight, because if I am grasping with the two hands, now the bottle is empty. If it is full of water, right, and the 2 fingers may not be sufficient enough to grasp it. So the weight is also playing a vital role. Similarly, the temperature, humidity, and positions, all these we need to calculate. These are the parameters we need to calculate. So see, A, B, C, D, E, F, what are these? These are the different parameters we need in the industrial applications. And in a depth sense, what are the values or we need to calculate what? We need to calculate the shape, size, weight, all these we need to calculate. And what are the sensors we can use, we can utilize to calculate that? So these are the varieties of sensors utilized for calculating such kind of values. Now see, there are the service for the disabled, as I told. Here it is the rehabilitation robot. Here different tray for food taking. This is a robot which is taking certain foods. Here is the teeth brushing. Now robotic teeth brushing is there, and the facial cosmetic is there. So robot is also playing a vital role in such kind of applications. So these are the varieties of other robots. I'm just keeping this part because a lot of other information is coming. So these are the different applications. Here it is in mining environment. Here we have a in mines we have to navigate the particular robot through different pathway under the mines, which are under the ground level. And there is navigation applications you need to apply. You need to go for obstacle avoidance, right? And also you need to go for tracking the particular object which you are searching for. In medical industries, a lot of applications. In hazardous environment, lot of applications. Then what is the future? If you talk about the future, because in India it is currently going on, but the other countries like Japan, they are developing. They are already ahead of us, right? So we can go for the uncertainty parameters we have to think of. We have to go for the non-observability. We can also think of the action under uncertainty. So these are the different future perspectives we'll come across. Now, these are the future plan across the globe, how they are going to develop. So now we are at 2020, 2021. So now intelligent robot has to be developed and they have to be utilized, they have to be used in different household activities. Not only the industrial applications, but also in the household activities. In 2030, it can be capable of performing at the human level, because till now the robot is not that much capable like a human being. In 2030, the robots they perform most of the household tasks, right? Because these are the different data I collected from different industry persons who are working in this particular area. So in 2050, the robot brains has to be developed, which can work on 100 trillion instructions per second, like a human being. Similarly, in our military applications, there will be such kind of scenario or future perspective is available. Now coming to our discussion, what we are supposed to do today, the mechanical part assembly system. In mechanical part assembly system, all of you know, there will be human beings. They can take, suppose say there are 3 parts available in the particular workspace, and 3 parts has to be assembled together to develop a new product. So you have to serialize the part 1, part 2, part 3. So part 1, you have a specific sequence, right? That you can say assembly sequencing, or all of you in computer science, you know, task scheduling. So that sequencing is a measure of activities in mechanical part assembly, be it mechanical or automated. So we need to know which part should be taken first, which part should be taken next. So that sequencing you have to do automatically or manually. So a vision guided robotic system, basically they comprises of 3 important parts. One is the robotic system, another is the vision system, another is the component bulk handling system, that we say is a conveyor belt in general. So vision system is nowadays we say it's a machine vision, or we can say robotic vision, or we are aware of the computer vision. So all of the algorithm which we have in computer vision is taking the role here. So here the scenario, let me go to the diagram so that you can understand the scenario, how it can go ahead with a particular task. So see, there are 2 scenarios where we can think of adding a vision to a robot. So here isolated vision system we have, and another is eye on hand vision system. isolated vision system, that means the robot is separately present, and the vision system, the camera or vision sensor, we say, is a separate system. Now they have to be integrated in such a manner, they have to do the task simultaneously. They can give the feedback. Once suppose this sensor camera is perceiving certain data from the object, and it has to send the information to the robot control. So that robot controller has to provide the data to the robot to perform the task. So this is isolated vision system. Eye on hand, that means the robot gripper or robot itself is integrated with a vision sensor. So this is a eye on hand vision system, where the hand is capable of holding a vision sensor, so which can immediately do the job of sensing the object or sensing the target. Now this is the assembly system which we proposed in our work. So this is the assembly platform. There are 3 varieties of parts of different color, different shapes, right? And one by one part is moving in the conveyor belt. So there is a iron hand camera system, iron hand vision system available here in this Kawasaki robot. So this vision sensor has to detect which part, which object it has to catch, it has to grasp, right? So it has to go on different processing. So you think of how minutely it has to do, how efficiently it has to do. Otherwise, suppose it is going to catch this pink color object and it is moving. It is in dynamic situation. It is moving. The conveyor belt is moving. So it has to capture the image. It has to process the image. It has to detect the shape, size, weight, everything, and accordingly, it has to give a feedback to the robot controller. So robot controller is going to take all this data from this sensor and it has to process so that it will give a data in the robot environment format. So there will be the vision sensor, what they have. It must have a frame grabber, vision processor, and different algorithms to process this kind of activities. So all these nowadays intelligent cameras, intelligent sensors are available, intelligent vision sensors are available. So in the sensor itself, in the camera itself, all these frame grabber, vision processing unit, all these algorithms are you can embed. So that is a, you can say, single device which is capable of doing or performing the task of a vision sensor. So now this is going to feed this information to this controller, and this is again feeding to the robot controller, and again this robot controller is giving information to the robot. So this is the scenario how the robotic assembly system is basically performing the task, and what are the in a computer science perspective, what can be done. So here, what can be the proposed methodology? What are the problems involved in developing such kind of solution? We need to identify, we need to define the problem specifically. What is the problem? Whether which varieties of, we are talking about the different shapes, or we are talking about different colors, or we are talking about different materials, different objects made up of different materials. So that we have to define properly. That means we have to analyze before before making the system functional. So we need to gather all these informations, right? Then we can go for finding out multiple varieties of solutions, and out of which you can choose which is the best solution. Then we can go for implementing, finding out the outcomes. Then after that, prototyping and testing the particular ideas is required. So these are the different stages we can come across while developing such kind of system. Development of a vision system, that's much important. Nowadays machine vision is coming, in the market. You can directly purchase, but you cannot directly use it unless until you will calibrate it as per the requirement. So you need to know which varieties of vision sensors is required. vision system. I'm not talking about vision sensors because vision system and vision sensors are different. So vision system, we need to choose which varieties of hardware we require for developing the vision system and how we can interface different other devices with the vision system. Just like there will be multiple vision sensors, multiple other sensors which can be integrated with the vision system. Because you think of the scenario just in the previous diagram, the scenario here, we capture the image of this object and accordingly we need to calculate the part geometry. We need to calculate, we need to identify whether it is the correct part we are supposed to grasp at the moment or not, and different coordinate values. So you think of what are the different functionalities, what are the different activities simultaneously we have to perform. So based on that, we need to know what are other devices, other sensors we can integrate into the vision system. Then motion planner. So once you know that I have done all these integration, then you need to think of the robot separately. The robot has to work on a space. That means you need to develop the workspace. I will come across these slides. So once the workspace is being developed, that means it is confined, the robot is confined to perform the task within that environment. It cannot go beyond that environment. So we need to develop that. And then you need to go for this assembly work cell development. Just like the conveyor belt, right? This is a cell, we need to develop that. How the part will be arriving on the conveyor belt, how it is to be dispensed, how it is to be fitted, how it is to be taken, you can say pick and you can place it somewhere. So all this has to be properly segregated. Then integration of the vision system. Vision system is capable of holding all the varieties of sensors. Now you are integrating the vision system with the robot control system, so that vision system, what it collects, what the data, what after processing what data it is supposed to feed to the robot, how it is going to feed. There are certain integration, certain interfacing is required. So you need to develop a software which is going to connect both the robot and machine vision into a single entity. Then only the robot can perform. So these are the different stages we need to come across so that we can develop a robotic assembly, vision guided robotic assembly system. So these are the different selection criteria which you need to choose which varieties of equipments you need for the development. I'm just skipping this. Now this is my physical robot which is available. It is available at NIT Ramkela, at NIT Meghalaya in both. So in this we have a Kawasaki robot which is having this gripper we are going to develop, right? So see, it's a 6 degree of freedom robot which can the capacity of payload capacity is 6 kg, and see that is fixed. This horizontal disc, vertical disc, right? This is fixed. You cannot change this. This is the properties of the robot, right? You have to work within this environment, work within this range. Then it can go up to this maximum speed. This mass is not much required, but whenever you are placing the robot, then mass of the robot is required, because otherwise it will be during the performing the task, it may fall down, right? So that the system, total system will be damaged. Now see, this is the vision system, or you can say machine vision. This is developed by the company NI, National Instruments. So here there are different cables. If you find, all these cables are connected with different sensors. There will be force and torque sensors we can connect through this vision sensor. Vision system, we can connect the vision sensors, we can connect the ultrasonic sensors, everything, right? So all these sensors we can integrate in this vision system. And the programming environment is the lab view. It's similar to if there are in the participant, if there are some electronics people or electrical people, they know how to develop the circuit, right? If you are going to develop a circuit, you just drag and drop the circuit. Suppose there is a resistor, that resistor symbol you drag and drop it. A capacitor, drag and drop it, and you can connect according to the requirement. So that's a kind of a programming environment lab is going to provide you. Here, it can integrate the MATLAB programs, it can integrate the C programming, right? So this LabVIEW is a multifaceted and programming environment you can use very efficiently if you know C any other programming language. And as I have already told, choosing the components is very much important. I have to choose the camera. These are the one of the Bessler camera, which is an intelligent camera, because inside this the processing unit is available, and this is the frame grabber. Now you see this particular component is available in vision system. So this is the particular component which I was talking about, which I am connecting to the vision sensor. So this is available in the particular vision system, so that I can connect the particular sensor, vision sensor, into this particular unit. Similarly, this is the most important mathematical phenomena we need to develop, because this is the space I need to choose for my robot. So robot has to understand this is my space within which I can perform the task. I cannot go beyond the task, beyond the environment which is being specified to me. So accordingly, the robot has to be programmed. Otherwise, because all of you know, the robot can reach to some extent, right? It has a specific properties, that is a fixed properties. Horizontally, how much it can move, how much distance it can travel, and vertically, how much it can move. So it can go beyond that. But if you are fixing it and doing the program, it can work within this range. So this is much important. Now you can see there are 3 parts available. Considering this is a conveyor belt, here it is a static environment. It's not dynamic, because there is no conveyor belt here. So in the static environment, this is ultrasonic sensor, right? This is ultrasonic sensor. This particular is a force and torque sensor, and here in this particular, this one is the vision sensor. So I have to develop this diagram. This diagram is the coordinate values I have to define for the robot workspace. So how do I define? That will be a question. How do I define? So you need to, because you have a table, suppose you need to know that this is my length of the table, or the geometrical value of the table. So the surface of the table you know, and you have the geometrical properties of this surface. Manually, you choose this endpoint to this endpoint, how much it is moving, and accordingly, how much the robot is reading. What is in the robot workspace, what is the coordinate values? Because there will be 2 coordinate system here. One is robot coordinate system and another is wall coordinate system. So the table is in wall coordinate system and the robot gripper is in robot coordinate system. So you have to have a proper mapping of that. So mapping function you have to apply here. Suppose say if I reach 5 unit, right, the distance 5 unit in the robot gripper, then how much coordinate it is covering in the wall coordinate. So based on that, the mapping has to be properly done so that it can move. You can specify the space. Just like this particular, I have shown here right length. So what is the reach of this robot in terms of horizontal directions, in terms of vertical directions, how much it can go and go up and go down. Because if it will go down, right? It can hit. It can toss the table. It can break the table also. So you have to know up to how much, if this is the table, then up to how much it has to go. So that also you need to define here. So there is a programming, we need to program the robots accordingly, the robot can do that. Now, as I told, there are vision system, there is a robot system. Now you need to connect the robot with the vision system. How do I connect? All of you know the IP addressing. So you need to, robot is a one IP, you have to program, and vision system is another IP. So they are connected through lab. So I need to provide the IP, robot IP in the vision system. This is the vision system environment. Which is the lab view, you can say the lab view environment. So see, if any of you know Visual Basic programming, Visual Basic. So Visual Basic, what you did, you drag and drop a particular object. Behind the scene, the code is generated. The similar fashion it is doing. So here I drag and drop this button. So it is going to develop this. And I am connecting this. This is a text box or something I have to put. And this, the properties I need to change, that it is a IP connection. So this is going to check whether the communication is okay or not, because if the communication is not found to be okay between the robot and vision system, then nothing will be possible. No data transfer will be possible. Let me give a break. Is it understood by the participant or not? Let me know. I'm asking to the participant, is it understood by you, or if you face any problem, you can ask me on the same moment. Okay. So I hope all of you are understanding the concept, whatever we are discussing. If any of you face anything, any difficulties, you can just message me or put in the chat box so that I can answer to the question. So this is the, with respect to the IP addressing, we are going to connect the robot and see, this is the robot IP address, like this text box. So everything is connected. So this is connected, this is the vision system, and this is the output, the communication system, which is going to show the status, whether it is on or off, or it is okay, or there is a failed communication. So that is to be clearly visible to us. Then once the robot is connected, we need to know the different parameters the robot is having. The robot power is on or not? Is there any error state available in the robot or not? Is there any control signal which is interfering in the robot or not? So all this you have to see, you have to look at. There is a tech pendant. Let me go to the robot. Tech pendant is there. Yes, this small item is the tech pendant. This tech pendant, what it is doing, it has all these keys through which you can control the robot. So here, if there is a key, that is the halt key, if you press, then the signal in the robot will show there is a interrupt. So that also you can easily visualize in the program. So this is the program you have to develop with the same link, because once the link is connected, the link is okay, then you can get this information of the robot, the status of the robot. Next, the servo motors. All of you know, because I have not gone through regarding the servo motors, which is playing a vital role in performing different activities through robot. So servo motor, the servo has to be on, then only I can say the robot is in on condition. If the servo is off, then nothing. The motor is not on, then the robot cannot do anything. So I should also check the servo motor position, the servo motor condition. If the servo motor is on, or you can say the power is on at the servo motor side, then I can go further. So there is an on condition or off condition also can be possible. Now here, see, those who don't know this lab view, don't have to worry, because it's not a very big programming environment which you cannot learn. It's a very easy programming environment, like Visual Basic, all of you know. And the problem solving skill is just same as C programming or Java or Python programming. So here, this is one of the important tasks. I have to go for setting digital in, digital out line number. That means if I am going to send one information, one data from machine vision or vision system to robot, or robot to vision system, whether it is taking or not. How do I know? Connection is okay, everything is okay, but data may not be transferred. So there should be a digital line to be clearly fixed. If I'm providing 9, it has to take 9. If I'm providing 1, it is taking 2, then there is certain error. So that also line number has to be, you can indicate that. So by basing on the line state, you can, if it is glowing, means it is, that means you can define. If it is glowing in green color, you can say it is okay. If it is red color, it is not okay. Or you can say if it is highlighted, it is okay. If it is not highlighted, it is not okay. So like this, you can define at your end. Now, this is the important aspect, as I told, the position, the current position of the robot. Because gradually we are coming across how to develop the workspace, right? Workspace development is a very big task. You can easily do other tasks, but workspace development is much important. So once the robot is connected, you need to know what is the current state of the robot, the position of the robot. So once you know the position of the robot, accordingly, now these are the coordinate values of the robot coordinate system. Now you can easily map it. Suppose the robot is at the center point of the table, and this is the coordinate. Now you can imagine how much distance I should travel to reach to the other corner. So gradually you travel and note the values. Note these values. You can do a programming which can travel and record the values, right, in an Excel sheet, and which you need to know, you need to utilize for further workspace development of the robot. So these are the different joint coordinate system, joint values. So this, see, this is the robot coordinate system, and this is the transform value. So joint displacement, this is, and this is the transformation variable. What is the, after transformation, what is the value in the world coordinate system? So similarly, the space, the speed also you need to, you can fix it, right? So for a simple move, what should be the speed of the robot, speed of the gripper, right? So everything you can just define it. So accordingly, you can think of, right, how minutely you have to do. Otherwise, there will be very big problem may arise. So this is the control system in programming environment. We have to develop that in x-axis. See, this is the diagonal, this is the y-axis, this is the x-axis, this is the z-axis, and this is the o-axis, which is the clamp. So in y-axis, that means horizontal, I have kept here. X-axis vertical. So if I move, take certain movement here, there is a bar here. So if I make a changes, the robot has to move. So this programming we have to develop. This is called robot axis control program. So you need to control the axis of the robot so that you can easily reach towards the particular object which you are supposed to grasp. And this is the program. And the overall integration, whatever we discussed till now, with respect to the system development, is this. These are the algorithms. You need to do this thing in a repeated manner, unless until you will not find a suitable developed environment. Now, as I have told, there are a lot of vision tasks, vision algorithm you need to apply to perform the assembly operations. One of the tasks is to detect the shape and size or weight of the object. So all of you are aware of edge detection algorithm. You are aware of corner detection algorithm. So you can apply these algorithms and you can detect the particular shape or size of the object. So before going to the different development with respect to the detection of or finding out the geometry of the object, we need to understand what is a vision. What are the vision senses available? So vision is the process of converting the sensing information or sensory information into a particular knowledge. That knowledge is going to give you the shape, identity, and different configuration of the geometrical configuration of the object. So sensor is capturing, is sensing the data from the object and is giving to you at the vision sensor level, at the vision system level, that this is the shape. So it is reading in terms of some data, it is connecting and it is converting into different shapes. So these are the different transformation you have to do. Similarly, there will be different varieties of sensors which can go for identifying the shape, identity, configuration of objects, right? Bad sensors are available, bit wiper, heat detector is available, touch sensors is available. So these are different other sensors available. So I'm just skipping this sensory sensors, different sensors, and go to the development because time is not that much. I'll share this PPT so that people can go through. Yeah. So this is there are three parts. There are three parts I have already shown. This is the first part. So I have to detect the part one. So in such a manner I have to detect so that I can easily find out. I can easily find out the grasping point. I can easily because through other senses I can find out the weight, material, all these I can find out. So this is the one of the example I have applied, that is edge detection technique, right? So this is a hybrid edge detection technique I have developed in my research. So this hybrid edge detection technique, which is talking about the fuzzy inference system plus the wavelet transformation. So if you because edge of an object is a important properties we are talking about in terms of detecting the object. While detection, the edge, there will be horizontal, vertical, or diagonal. So diagonal, lot of pixels are available, horizontal, vertical, and there are corner pixels. So all these different edge detectors which are readily available, just like Canny edge detector, which is widely used, Fluid, Sobel, Roberts, Laplacian of Gaussian, mathematical moment base, mathematical morphology base, wavelet base. But in hybrid, what we did, we combine the advantage features of fuzzy inference system and wavelet, because wavelet is only detecting in a efficient manner the pixels which are in the diagonal. But if it is horizontal one, the particular fuzzy one cannot detect. So what you need to do? You need to do hybridizing the two techniques and make a new technique, so that the horizontal, vertical, and the diagonal pixels it can easily find out. So this is the second object. This is the third object. So see, there are three parts in this scenario. We are going to assemble. So this is the assembly, because after assembling also we have to detect, we have to check the quality, right? So once it is being we are identifying the object properly, then we can grasp it, and the robot has to minutely take and put it in some place so that it can be easily visible. I'll show you a video which we developed in the lab. So these are the two parts, male and female joint. So this is the same technique we are applying. Here I have skipped the corner detection, corner points. I have skipped showing in front of you. Only edge part I have shown here. So this is also one of the way. Now, once you did all these, whatever image processing technique you are going to apply, now the next thing is, how do you feed to the robot system? So to feed to the robot system, what are the vision sensor is providing to you? What are the after processing? What are the data it is providing? So it is supposed to provide to the robot. How, in what way it can provide? There are two varieties, and this, as a whole, the technique is said to be visual servoing technique. Visual servoing is a mechanism to which is a vision-based feedback control system. Vision-based feedback control system. The vision sensor is sensing, processing, and going to give a feedback, give a information to the robot to do the task. So this is a feedback control system. That means it's a properly connected system. Now here I have, because I have two cameras here, because in the robotic assembly system we need to you need to have multiple vision sensors. So there is an object A, and that's a current position. This is the actual object position. So you need to see this sensor is capturing this information. This sensor is capturing this information. So two sensors are capturing differently. Now you see, this is the initial position of the robot, and the vision sensor is capturing this information also, along with the object position and the robot gripper position. So this is going to catch it. How? What are the control mechanism we need to apply? There are basically two varieties of mechanism. One is image-based control, another is position-based control. This already we have discussed, eye to hand, eye in hand. So this is overall robot navigation system under visual servoing technique or mechanism. So this is the robot environment, and there is a video feed. The vision sensor is going to feed, is going to collect the video of the environment. So this is there are a lot of applications, a lot of mathematical processes to be applied here. Like you need to apply the picture extraction technique, and once the picture is being extracted, then that is to be fed into the controller, where the control laws are available. And once the control law you are applying, based on the control law, it is going to control the different joint of the robot. So the joint control parameter is also going to coming into the picture. So all these are in a loop concept, everything. So this is the overall diagram of the visual servoing system. And in image-based visual servoing system, here the robot can work based on the imagery information. It is being captured through the robot sensor, through the vision sensor. So here the object image is being captured. So extraction of the features is there. Then some of the things, because there will be a lot of features, all features are not really necessary. Suppose you only need to grasp, you don't need the material, you don't need the different other geometry. So you need to grasp. So you need some features through which you can calculate the grasping point. So that is to be given in the feature space control law. Here the control law is to be developed. Then once the control law is developed based on this feature map, it is going to feed into the controller of the robot. So through which we can control the different joints available in this. This is the position base. So the robot is going to the same technique, but little bit information whenever you are extracting, that is changed. That where the object is present, what is the position of the object, all this is important. So that is called, these are pulse estimation is required here. Why I have given a cross mark here, circle and a cross mark, because there will be lot of processing to be based on the extracted features, lot of processing is to be done here. Then in a Cartesian space, it is going to develop the control law. Similarly, hybrid visuals are going. I'm not going to tell you much details about this. So these are the different scenario of visuals are going. And this is the two important comparison between this image base and position base. Here, the control law is derived in image space. Here, the control law is derived in Cartesian space. No object model is required in an image process. In image-based visual surveying, object model is not required initially. But in position-based system, the robot should have a priori the model of the object which it is going to capture. It is going to grasp. And this is the one of the mathematical problem, singularity problem. Whenever you are developing a feature matrix, the matrix, if it is singular in nature, it will be too difficult to handle such kind of matrix for further processing. So in image-based visual surveying system, the singularity problem occurs. So to handle that singularity problem, different mathematical operations you need to perform. But it is not affected by the singularity problem because of the Cartesian base. And similarly, we need to maintain the field of view, that where the robot workspace is defined. But here the field of view can make an issue because you are working with the position of the particular workspace. If the object is not in the workspace, is just at the border of the workspace, there may be a little bit issue. And in the both cases, camera calibration is an important task. But in case of image-based, camera calibration error is not that much important. But in position-based, calibrating the camera is very, very important because we are going to calculate the position. We need to estimate the position. And noise is playing certain role in such kind of scenario. So I'm just skipping. I'm just going to show you what my development is. This is a visual surveying technique. Here I have applied this feature extraction. This feature extraction. This is the current image. Here the feature extraction technique. Whatever I am going to take, that's a feature selection. You need to extract the feature. You need to select the feature. So there are two algorithms I have to apply. Which are the features I need to extract, and which are the features I need to select for further processing. So this is the based on this the control law is to be developed, that in a feature space, and again the feedback will be given to the robot. See, so see, you might be looking at the images here. Different noises I have added. Noises means, all of you know, is it looking like a original image? No, it is translated. That means elongated. That means I'm just dragging the image from two corners so that this image is looking like. So different varieties of image you have to consider for the development a good development of a efficient algorithm. So you need to rotate, you need to elongate, you need to translate, you need to change the position differently. Based on that, you need to check the algorithm whether it is performing betterly in a better way or not. That also you need to find out. So if the convergence result is meeting at a particular stable point, then you can understand, then my algorithm is okay. I'm just skipping this part because this is a research dimension. Yeah. So already we have seen this scenario where we have taken the robotic system, that is Kawasaki robot. This is the gripper which we need to utilize, and these are the different sensors which in the particular research I have shown you. I have used. These are the different sensors I have used. So the different purpose of the sensor, vision sensors is to acquire an image. Distance measurement, I need to go for the ultrasonic. Capacity proximity is going to check the material. And force sensors, how much force you are supposed to apply on the particular object based on the material, you can calculate. So this is the scenario of this is the intelligent gripper we have developed in the lab. So just like in the previous diagrams I have shown, the gripper is having a lot of sensors, that we say intelligent gripper. So this I am skipping. There are different parts. This is another part, 3D prototype we developed, and we are measuring the shape, size, different geometric parameters based on different sensors, right? And how much force we are applying on this particular object, that also can be calculated. These are the different all of the examples. Just like this is the programming environment we have to develop. These are detected edge alert view I told, different corners. These are the other parts. For assembling purpose, we developed this prototyping model in 3D printers. So these are the different varieties. See, this is the proximity sensor, the distance measurement it is going to calculate, right? This is a force and torque sensor. This is the part which we are talking about. This is the scenario with other objects. Already I have discussed this. These are the background framework for the particular developed system. And this is the actual model. This already you have seen. So this is all about whatever I told. This is all about the topic I am supposed to cover. Now I am open to any discussion if you have anybody. Yeah, Dharambir, Dr. Dharambir.
Yes, sir.
Yeah, anybody is having any question, we can discuss on that.
Any questions would like to ask questions, so you can raise your hand so that I can unmute you.
Okay. Because of the time constraint, I cannot cover all the things we are developing right now. For the basic thing, whatever we require at this level, I hope I covered.
So I think no any participants.
Yeah, I think there will be two options, Dr. Dharambir. Either they understood or they don't understand, right? There will be two options because some of the research aspect I included in the discussion, it may not be suitable for everyone, but those who are working in these areas, they can understand easily.
But it was very interesting, sir. You have shown Kawasaki robot, which is established in your lab at NIT Rourkela. So really, it was
Now,
very interesting.
At NIT Meghalaya, we are working with multi-robot cooperation along with IIT Delhi. Yeah, Dr. Chinmay is there.
I think you would like to ask a question.
Yes, yes, yes. Okay, Dharambir, anything?
Chinmay sir, you would like to ask any question? Chinmay sir, you can unmute. Absent request for unmute. Now you can unmute, sir. Chinmay sir.
Good afternoon.
Good afternoon.
Actually, I have no questions. I would like to thank I'm really grateful for the time you spend in careful preparation to present us with meaningful concepts on the topic that vision guided robotics assembly applications on this robot intelligence. Really is such a wonderful opportunity for me to attend, and it has given me a chance to learn many things. And what I have learned, I will definitely improve on it with extra knowledge from the next FDP. And thank you, Dr. Balabantaray sir, for such a wonderful session it was. And I'd also like to thank the organizing team, especially my friend Dr. Dharambir Yadav, for this interesting and useful FDP on robot intelligence. Thank you, sir.
Thank you.
Thank you, Chinmay sir. Thank you, Bunil sir, for giving such a nice informative session. And it is nice to see you, sir, after a long time. So I think we are
Yes, after a long time we are meeting.
So, okay, sir. Now we can conclude the session.
Okay, thank you.
It's a lunch time, so okay. Thank you, sir. Thank you, sir, for joining the session.
Thank you.
So we have lunch time till 3:10. So we have another session, hands-on session by Dr. Rajesh Duri Asad. So we'll meet again after lunch at 3:10. Thank you.